Okay, friends, let me know if you have any problems with hearing and following the questions, following the lecture. If you have any questions, let me know. My chat window is open. Today, we are going to move to requirement gathering, task analysis, and evaluation part. I will start with requirement gathering, requirement analysis related to human-computer interaction issues. User interface requirement gathering process, task analysis, and interface evaluation. So generally, this is the customer, and this is the engineer. And this is what we see in most of the case. The agreement about the requirements on a project is usually not defined very well. And when the requirements are not defined very well, the end product becomes unusable or not satisfactory for the customer. And that may result in even litigations and financial issues between customer and the engineer. Therefore, written and well-documented requirement gathering process is essential because it also forms a contract between customer and the engineer. Also, you work as a team in big projects, so the agreement between team members can only be supported if you have requirements about the project written down. In your graduation projects, we expect you to write down requirements because over the time you tend to shift from the original requirement, original idea, end up with a totally different project or a project which doesn't satisfy success criteria or initial criteria. So therefore, it's a very nice nice and essential thing to have a good requirement gathering process. And how we do it? We do it yeah. Do you see something here? Like stop presenting box?
Where? In our Teams page?
No, on my share screen.
No.
Okay, it's on me then. For example, on my screen, gathering, the word gathering cannot be read because there is something on it. You can read gathering, right?
Yes, we can.
Okay, no problem. So we should focus on how, what, and why we are gathering things for the requirements. We see that issue a lot in many times. And one critical example is your graduation projects. you have difficulty gathering requirements to present başarı kriterleri and success criteria and necessary functions. So what are we going to do is an interesting thing, and most students usually have trouble finishing that part. To do that, you have a task. That task, that process, the original idea must be analyzed by focusing on how a person is going to use it. And when you do that, there are methods such as ethnographic methods, understanding person, focusing that not all people are the same. This person could be different than the other one and other one. So if you are going to develop an application for a general population, you should think all the different user types and make sure that all those users will be able to use your application. How are you going to define it? You should observe. Start by observation. Observe those users, understand those users so that you can make sure that the application will be usable. One factor is to understand what we are going to be doing in the project. What we are going to be doing in project development is to build systems for others, not for ourselves. So, therefore, we should analyze other people, not ourselves, not our taste, and because all people are different, and since we are programmers, we are engineers, general population logic is quite different. Therefore, we should understand the work environment, we should understand the task, then decide how to implement the user interface. Otherwise, functionally, it may work, but nobody can use it except you. Given a specification, they ask you to do a system that does a task X. You go to a Python programming language, you run your application and you say that it's running, I am done. No, you are not done. It has to be in a usable form. It has to be in an application form so that it will be usable by general target population. I wouldn't say general, but target population. So how the success is defined is interesting. If it's a scientific problem, if it's an algorithmic issue, obviously it is not for general population. But if it's an application for general population or for consumers, success is defined not only by working application, but also a usable application. In real cases, there are real-world constraints, including financial constraints. And there is an environment constraint in indoor, outdoor, etc., mobile. User characteristics depending on the country, depending on the region, age, okay, and gender or professional differences. So how am I going to make a conclusion? I should do task decomposition. Task decomposition is like make T. Okay, make T, but how? Get water, boil, put T in, wait. So you have to decompose this task. Could be one level, can be multiple levels. Wash, filter, put. Wash could be decomposed with multiple steps. So task decomposition. Sorry for this. Task decomposition can be done in multiple levels. And what we say here is that hierarchical task analysis, which I will come later. That's the first level. That's the first level, second level, and third level if necessary, etc. So that developers understand what is the original task and what are the steps to be performed, what are the alternatives to be performed. In real world, there are constraints. Since we are engineers, there are real world constraints. Time constraint is very critical. Cost constraint, which is related, of course. Size, footprint, weight, power, price, computation power, CPU type, memory size. They're all constraints. Computer memory, also related to the cost. And consistency with overall product line. If you are a company launching certain different products, your new product should be compatible with your old product. Therefore, you need to provide consistency. You should also develop products that are consistent with other products, because users are familiar with the other products in the similar other products in the market. You need to provide backward compatibility when you're developing an application so that old files, old users, previous versions should also be supported. So as you are developing your application, you need to focus on future generations of your software so that give room such as version number in your files so that when you launch version 2, your files with version 1 have indicators that are recognizable by the version 2. If you don't have any version management intention in your version 1, you may have trouble managing those in your version 2. So be prepared for backward compatibility starting from version 1. And as you develop a product, it has to be slightly different due to the requirement of competitiveness. It has to be different so that you can sell it. More advantages, etc. So those are the real world constraints enforced by market and your boss. Okay, those are the real world constraints. In order to understand tasks, you need to organize the task data. You need to gather data, organize data, and represent data so that these will be transformed into user interface and application design. For that purpose, you need to make interviews, observations, surveys, questionnaires, documentation, immersion. Immersion means going there and working. And UPS has an interesting application to be used in the field. And the guy the computer engineer who designed the software for the UPS worked 2 months in delivery before starting designing the application. Such as if you are going to work in Getir, for example, or Hepsi Burada, Hepsi Express, etc. If you are going to design an application to be used by courier people, then what you should do is, generally it's a good thing to work as a delivery person or work together with the delivery person for several times, then understand how it feels and what are the necessary things. That's what we call immersion, being in the place, either by visiting or working. Then take notes and organize those notes cards and do some brainstorming and use some computer tools if necessary to label those data, and then make lists, outline matrices, do some explanations, do some flowcharts, and then at the end design the application. At the end you can design application. That's how it should start. Otherwise, if you are given only requirements by the customer or by the boss, it's not going to work, because once you finish it, you will realize that there will be more requirements and there will be more features. And if you don't take those into account at the beginning, you will have difficulty in restructuring your application. This is a nice flow chart. It starts from observation phase and data collection phase and design phase. So first you do some observation, interview, and consultation with the users. Then you collect some data using testing and evaluation, and do some literature survey, then do analysis and interpretation, and final report. That's general flow chart of usability research. Not product design. That's general flow chart for usability research. I put it here for a general reference. There is an initial research part and design data collection part, and then design and analysis part. First, you start with observation, then you do experiments if necessary. Data collection. This is design documentation. What are we going to, let's hear. What are we going to gather? We are going to gather activities, artifacts, and relations, not only computer-oriented, but people-oriented. Office or environment, papers, whiteboards, who is going to call, phone book. So in a general setting, a computer in a business case is used in a kind of special environment. You have calculators, you have money counting machines, you have phone, which is handy. You have papers, people calling each other, people talking to each other. You need to understand the business case and environment, artifacts and activities in order to design the application correctly. So you need to write them down, take pictures if necessary. Here I am assuming that there is a real process and they need an app for it, and you design an app in new process. So there is a real process. You watch this, develop an app, and you define a new process. That is usually the case. For example, you are doing something for Yemek Sepeti, right? For delivery application. Food delivery is not new, so there is a real process, ongoing, real process currently available. So you work on that process, develop the app later, and then define a new process with your application. Most of the time, this is how life is. You don't invent new use and the new application together in most cases. Sometimes it happens, but in most cases, there is a real business case already in place, and you are asked to make an application and user interface to improve or facilitate that process with the computer or with the mobile application or with ubiquitous application. So it's not just computer system oriented. You need to understand the person part and the environment part. Then that brings task analysis. We need to understand the task. What is happening here? So try to first focus on observable behaviors. What are the practices, methods, steps, objects used in a real setting? Learn what users do, why they do it, how they do it, when they do it, with what tools people they do it. So if it's the Yemek Sepeti or if it's a hardware store in a village, if it is grocery, you should observe what people are doing there. If you are going to design an application to facilitate that process. Your new system usually come to that place to facilitate new architecture new business architecture may change some of the methods that are already in place. So there will be some business changes, but usually the requirements are staying the same because there is a business going on. If it is a stock exchange, like Borsa Istanbul, they are using 9X system. The business, the functions they perform has been around over 100 years, stock exchange. However, they are doing it with computerized interfaces. So some functions will go away, some new functions will come back, but general business case must be analyzed in order to bring a nice feature. So that's how you start. The analysis is done in multiple dimensions, multiple levels, multiple dimensions. One, immersion, ethnographic study, learn by doing. So when you are, as I said, when you are going to develop an application for teachers, go and teach for some time. If you are going to develop an application for delivery person, go and work as delivery person. If you are going to develop an application for factory workers, be in factory. I wouldn't say work, but be in factory with the workers together. So visit them. Now we are moving to observation, so that you understand the real case. One thing is thinking out loud, which we do a lot. Thinking out loud means ask person what he thinks, what he is doing, what he is going to do, why he is or she is doing the tasks as they are performing, so that you can take notes or you can take the video. If you take the video, then watch that later with your programmers. People will understand what are the requirements, so they can write down correct things. That's what we call thinking out loud observation. Third one is the cooperative evaluation. I'm going to move on them one by one. You and the user evaluate and discuss the task together. And we interviews, questions, forms, focus groups, people get together and discuss how the new product should be. And then you take the video of that meeting and then listen what people say about the possible future product or current problems. And if there is documentation, like legal documentation, like yönetmelik, kanun, etc. So those documentations must be studied. And if there are other products in the market, like banking applications, like delivery applications, whatever. Today I'm talking about delivery applications, Getir Yemek, etc. So if you are going to develop a competitive product, look at the other products, and there is no problem in making your application similar to other applications, because it brings because it brings consistency to your product. understanding multiple people is called as interpretive analysis. It can be done with experiments, sometimes formally, sometimes objective, formal and objective. When you do experiments, usually results are not debatable. But interpretive analysis, explanation. Again, even if it is more subjective, it is also open. I mean, 90% of the time, it is objective. It is less objective, but still, when done nicely and honestly, it is objective. It is concerned with humans and human explanation. So being objective is difficult, actually. There are users involved in interpretive analysis. So you should do it. You should do and observe, listen, watch, and then write. So it's not predictive approach. You have to view things, then you need to write down. You don't have to do it in advance. You cannot do it at home by yourself. You have to go to users, you have to go to field, and you have to get along with actual users. And that is not predictive. In real life, there are quite different issues if we compare it with labs. Labs are also great places to make experiments, but in isolated cases. If you have an isolated problem to focus, you can do lab experiment. But if you are going to understand the task, if you are at the beginning understanding requirements, then lab is not as good. Real life is better. Lab is not real world. We cannot control all variables in the lab. Content is neglected usually, and it is kind of artificial, and tasks are short, because if tasks are long, you cannot measure the results. So isolated problems, labs are good, but for general understanding, you have to go to the field. How do we make interpretive analysis? The first one is the ethnography, learning by doing. Second is contextual inquiry, asking questions about the topic. Field study, ethnography, similar to ethnography, and observation, just watching the users. So let's focus on ethnography, and it is contextual study, and basically putting oneself into a situation you want to learn about, such as observing people in their cultural context, observing animals. I know one architect that builds villas for rich people. It's kind of a famous architect, and he said if he is asked to design a villa for a person, he asks to live with them together for 3 days. I found it very interesting. He said he asked that family to stay with them 3 days during day and night, and he learns the habit of all the habits of the family, the living structure and the necessities, how they use the kitchen, how they sit together, etc. So he understands the environment in the family, then goes back and designs the house. So that is what he was doing, observing people in their cultural context. If you are going to develop a system for the kitchen, industrial kitchen, for the restaurant kitchen, or interface and application for a grocery store, you should be observing people in their context. And it's quite different than what you think generally. All professions are different from each other and have their special context, and both culturally and physically. So you need to go there and watch, and if possible, be one of them and interpret those results later. So sometimes this is considered very important, because when you do laboratory experiment to understand a person, or if you call the person in the office and ask what they think, it is kind of artificial, because experimental or the people who is asking question directs the worker. So that becomes unnatural. They don't talk. They don't give actual information. They don't know what to give actually. So the idea is to get into working environment of the user. Don't bring them to the office. Go in their environment to understand how actually the job is. And you need to be a good interpreter. Just collecting data is not sufficient. Also, you need to interpret the data to help designing the application. Developing an interface, an application for truck drivers or taxi drivers. You need to drive taxis, or you need to be with them all day to understand what are the necessary issues, what are the problems, how the task is defined. If you know that, then the application will be very successful. One interesting example is medical applications or hospital information systems. In Turkey, many of the applications, many of the companies that sell hospital information systems are started by, successful ones are started by medical doctors. Their software designers are medical doctors. I know a few. Since they have been in the process as medical doctors, they know what is necessary. They know what the problems are much better than a computer engineer. So the application then becomes very successful. Okay. Oops. What's up? Where is my cursor? Okay. So briefly, we need to understand the user. We need to understand users' goals and values. We need to understand groups' interactions and things that are in the culture. Try to make implicit domain knowledge to explicit domain knowledge. So try to find unknown things and document them. And we should do them in unbiased fashion, such as Apple versus Microsoft. So that kind of debate should be avoided. And if there is a current system, try to find problems. Criticize it. Make critiques about the current system. So try to find problems with the current system and write them down. That will help a lot. So learning by doing or observation. This is learning by doing an observation is very famous for people who are studying animals. You go among them and sit and take notes, take video to study. So audio video recording, interviews, observation are keys. Okay. In a market, in a taxi driver, truck driver, in a government office, okay, anything, or a field engineering, structural engineering, forestry, you need to go there and watch. Okay. Carefully observe everything about users in the environment. Think of describing it to someone who has never seen this activity before. So if you can explain it in that way, that means you are defining it correctly. What users say about the current situation is also important. Plus non-verbal details. If they don't like something, if they spend a lot of time on doing certain task, you should make note of it, because that makes that task very difficult, time consuming. So in addition to what they say, also take notes about what is happening. What are the interesting things? Language and structure of the structure and language that is used in the work environment. Group actions, individual actions, culture, work aspects such as office environment, business practices, rooms, artifacts, things, work standards, relationship between workers, managers. You need to observe all those to understand what is going on in the office. You need to understand the company practices. Interviews are important. To have that, you need to go through questions, have a questions listed, but once you finish the questions, you need to have a room for additional discussion. Usually, people start talking in this discussion and say that we are designing a new application. We are not examining you. If you say that, that's very important. If you say that, they start talking. They want to help. All the people want to help. Generally, if you are going to develop a new application, or if you are going to develop new version of the application, they start talking and they try to help with the problems. They explain problems to you. And at the end, ask them about what should I have asked as a last question, and they start talking at that point. Also, video record the interviews or audio record the interviews, depending on the permission. You should start from the preparation steps, understand organization policies and work culture, familiarize yourself with the system, set initial goals and prepare questions, and then plan the interview. Go to the field, observe or interview users in the workplace, collect data by taking notes or by taking video. Follow any additional contacts started during the visit, and also make the recording for later reference. Come back to office, tabulate data, analyze data, quantify and compile statistics about the work, such as how much time it takes to enter a certain amount of information, such as how many steps are required to finish a task, etc. What is the difficult part? Those questions must be answered. And you need to report this in your analysis. One is the engineers. The other part is management. This is upper level management. This is your friends to developers. Developers must understand the real life scenario. If you have 50 developers, it is very hard to take all 50 people into the field. So brief videos or a good report designed for these 50 developers will help a lot. Otherwise, they don't understand the real life scenario. They go by themselves in developing the application, and there will be mistakes. So make the reporting available for the engineers and the management. One thing for collecting and organizing information is affinity diagram. In the affinity diagram, we write down each observation in a small piece of paper, usually Post-it by 3M. We put up those observations on the board, then change the locations of the papers depending on where they are related to. Group them and give names to groups, then continue grouping subgroups, and then there will be hierarchy, and that will go into application design. That hierarchy. So there will be menus related to that hierarchy. Let me show one example. This is one example in affinity diagram. So small pieces of paper stick to different places. So they are grouped, and then this is one group, this is another group. This is another group, so there is another group here. So these will be different. Menus in the application. These are the things that are related to each other. All the functions. If you write this down on the board, it's also doable, but relocation is difficult. So since it must be easy to relocate them, it's a good idea to write them down on small pieces of paper in this phase. Another one. Okay. This is the board version. In the board version, you can relocate by rewriting and erasing, but that's kind of more difficult, so people don't do that. One thing about design is, hard to change. If a tool is hard to change, it's not good. Therefore, we need to find ways to make changes easy. Therefore, in this case, change is easy. In this case, change is easy. This is relatively less easy, but still possible. We see this a lot in the companies, in designing applications, because boards are available and nobody's spending time on cutting papers and writing things on it. They use boards, but using paper is much better. At the end, you take the picture and you can record it. So this work can help designer to gain an rich assessment about user needs. So what user need in real environment is understood for requirement understanding. And true nature of the user's job is discovered. It allows us to play the role of the end user, so we can look from the eye of user, which is very nice. And open-ended and unbiased nature promotes discovery of the new possibilities. Ethnographic study may yield more unexpected explanations, so that you can discover new possibilities in the field. If you do experiments in the laboratory, it's quite limited, but in the environment, you can say, why don't we do this task in a different way? So it is open for new discoveries. In the field, you can have qualitative and quantitative discoveries. Both are important. Proje başarı kriterleri. Success criteria. It could be the findings are both qualitative and quantitative. Quantitative findings are how fast, how long it takes, what are the errors, how many errors are made during the day, how many backups, how many go backs, etc. So if you count things, if you count events in the task, those are quantitative. But if you observe what is good, what is bad, what is difficult, those are qualitative. Something easy is usually is qualitative, although you can measure the time it takes. It can have both. Both are okay. For of observation or interpretive analysis. It takes time. Getir yemek is asking you to write an application, and you say, my professor said we need to make a field study, so I need to work as a courier before designing the application. They say get lost, so they may say get lost. Or as I said, if you are an architect and people ask you to design a villa for them, you ask, can I live with you 3 days? And they don't like it. So it takes time and effort. Only small number of participants can be manageable. You cannot work all the people in the factory. You can only visit and work with some people in the factory. Results are usually qualitative. It may be difficult to present and use, so you need to be careful and efficient in presenting the results. It requires good interpretation. Identifying and extracting interesting things is challenging, so you need to be good in this. You need to be a good writer and good observer. Sometimes things are such as typing certain numbers. Things are seen easy from the distance, but actually they are very difficult. So you need to find them and relate them. They are skills that are acquired over time, not an easy task in the environment, such as forklift operator. Forklift operator, it seems very easy from the distance, rotating around it and docking to some aisles in the factory, but it's an acquired skill over the years, and a beginner forklift operator may be very bad with respect to a skilled one. So if you are developing an application for the forklift operator, things that are seen easy at the first look may not be as easy in reality. Sometimes you have a company, software development company, Software Development Company, SDC. And this is Arçelik factory. They ask for an application. This is Software Development Company. They ask for an application for a new task. And what you do is visit them. Okay. And develop them. Stay there. So you make the development not in the company. You move development to the actual field. That is what we say, study is being done in conjunction with system being developed. Help keep focus on user throughout the design, requires lots of time and coordination. So you move to a place where is the target consumer or target user is in, and you do continuously ethnographic study as you are developing the interface and application. That kind of work is very fruitful, very good, but it takes quite effort. For small companies, it is sometimes better. Banks are doing this for some partners. Some other factories like textile also utilizes this. For example, you are developing an application for the textile factory, and the whole company moves to a textile company. They give you a room inside the factory and you study there. And every day, every hour, you visit the factory floor and gather information. That is quite fast and fruitful in terms of development. But it requires coordination. It requires time because you are there. I mean, you should spend time in the factory. This is observation thinking out loud. We sit with user, doing activity. We encourage user to talk. We take video or audio record, and we come back and analyze. Thinking out loud means there are some tasks where people don't talk, such as using Excel. They don't talk, but thinking out loud is like giving lecture. Giving lab lecture. So you can listen to the person, you can listen to worker, and understand what is the problem, what is the task. As you see, I am always focusing on existing task. In computer applications, in many applications in the industry, there is already a task in place. What you are going to do is develop a new application for the same task. Therefore, it is very essential to understand the existing tasks and existing application, if any, the old application, probably written 10 years ago, 20 years ago, understand that and what people are doing with that. So your new application will be better and also will be compatible with the tasks. Thinking out loud is similar to this kind of setting if it's a desktop environment. In the cooperative evaluation, we put more responsibility. We give more responsibility to user. User is viewed as a collaborator in the evaluation. Therefore, we criticize the application together. We criticize application together in both good and bad parts, of course. It's a more relaxed version of the thinking aloud. Evaluator and participant can ask each other questions and discuss. So there will be interruptions in doing task, but it's like going over the existing structure. Okay, so should we give a break for 10 minutes?
A break would be good.
Let's come back in 10:50. Okay, I'm back. So we were talking about cooperative evaluation methods. We sit down in front of the existing application and work together with the user. We ask questions each other and we discuss and we evaluate together. That's what we call cooperative evaluation. And this guy here is the user interface guy, and this girl is the worker. That's the user. So this guy asks questions to stimulate the research, and basically it's better to take video and make notes sometimes together for later analysis. In the cooperative evaluation, we try to find errors early in the prototype or a previous version of the application or a competitive application. We use tasks. Experimenter uses tasks, also talks to participant throughout and asks questions. And at the end, we discuss what we have done. But that is called as debriefing. Discuss briefly at the end. Okay. Last one is the interview. In the interview, we discuss with the user. It is more structured. We start questioning the user. It's efficient, but it requires some training about the interview, because if you are not good at interview, it will take long time and you will not get any answer from the user. So you have to be careful and trained to make interviews. It is kind of, if it is unstructured, just discussion, havadan sudan konuşma, then it is inefficient. However, training is interesting. Domain knowledge also is required in this case. If it is unstructured, you need to ask certain questions on the fly without preparation. So that requires domain knowledge as well, in addition to interview process. So unstructured interview is less efficient, but may reveal more facts. Best of both worlds, semi-structured, start with focus questions, move to open-ended discussion. That's good balance. So 50% of structured, 50% of unstructured is semi-structured. Training is actually process plus domain knowledge is required. In order to understand domain knowledge, you need to study the task before going to user. Before going to interview, you need to study the task. Maybe yeah, I see this in a famous TV example is Fatih Altaylı. Actually, he studies the topic before invites a speaker. So as doing the interview on TV, he exhibits some domain knowledge, and that makes the interview more fruitful rather than purely structured questions. In the semi-structured interview, which is the best for user interface analysis and planning. Please first know why you are asking the question. Some people ask questions just to ask a question, which is not relevant. So when you are asking a question, make sure that it helps you to understand the task. These are the examples. For example, how you perform tasks, why do you perform tasks, under what conditions do you perform, what do you do before you perform something as a task, what information you need to, what do you need to communicate with, what do you use to do certain tasks, what happens after you do task, what is the result or consequence of doing a task, what is the result of consequence if not doing the task, etc. So those are the things, questions that helps you to understand the task and the operation in the environment through interviews. And at the end, you move to open-ended questions. Why do you do this? How do you do this? Why do you do this and not the other way around? And what has to be done before you can do this? So let people talk and explain their feelings about the task so that you can understand some clues and insights from their talk. And at the end, please show me the results of doing this. What errors, do errors ever occur when doing this? And if the answer is yes, why the error occurs? How do you discover errors and how do you correct the errors? And also encourage some different talk. If user says something different, ask further questions about that different part. Maybe user is trying to tell you something without realizing. So encourage additional discussions and digressions. And the last question will be, what else should I have asked you? That is the last question in the interview. And if anything remains, user will tell you. Interview part is finished with the user, but also there are people that we call domain experts. Domain expert is kind of the manager or people who regulates it. It describes how it should be done. If it's a taxi company or if it is an let's say gas station. In the gas station, you have the pump. This is pump. There's a guy. There's a car. There's driver. So there's an office building. Let's say OPET. Okay. So this is the pump guy. There is an interface here. There is another interface in the station. So a domain expert is the OPET officer who is responsible from the operation, tells the person approaches to the gas station, then the pump guy goes there, asks, etc. So it explains how it should be done, but in reality, this pump guy first opens your gas tank lid without asking any questions to you. They just open your gas tank. Maybe you are asking for something else. So not necessarily how it is done, but expert describes how it should be done. But it's also important because there are some regulations and critical points. Those critical points are sometimes important. So domain expert in the interviews are also important in designing the application. If you have to follow certain rules and procedures for certain reasons, then you need to talk to domain experts. Let me answer this phone and say I'm busy. Efendim, dersteyim şu an. Okay, bye bye. Tamam. Dersteyim dedikten sonra konuşmaya devam etmelerini anlamıyorum. Tamam, sonra ararım diyebilir yani.
Çıkabileceğinizi falan düşünüyor olabilirler belki hocam.
Ya dersteyim, ya kapat yani dersteyim dediğin zaman sonra tamam, derste böyle bütün gün ders değil ki yani. Biraz sonra bir daha ararsın. Okay. So domain expert interviews are necessary. We have the examples for questions. Questions and Likert scale. Usually you have 5 or 7 scale here. Must be odd number, not even. So 4 or 6 is not an option. Make questions clear and specific. Ask some closed questions with range of answers. Sometimes have no opinion option. Some others, sometimes other answer option. And 1 or 2 people test run reveals that this question is wrong. This question is repeated. So when you do a test interview question form, which is named as questionnaire, please test it with your friends or 1 or 2 people so that there will be errors and those errors will be revealed, will be found. When you design a question form like that, you don't see your faults, so someone else will see them. Please test it with 1 or 2 people. This is what we call Likert scale. Likert scale uses odd numbers from 1 to 7, for example, agree, disagree, agree, disagree. You can use just words or numbers with the words. Make sure that it is understood, the direction. Sometimes people understood it oppositely. When they understood it oppositely, the whole question form will be incorrectly filled. So it should be understood correctly. Make sure that it is understood correctly by the users. Ranking the importance of the tasks are interesting. When you have the list of tasks, list the 4 more important tasks that you perform. You ask these from the user. List the pieces of information you need to have before making decision about X in order of importance. Are there any other points you like to make, etc. So talk to the user. Sometimes talking to user is not sufficient, or they don't talk, they are too afraid. So what you do is bring them together, bring users together. you are going to design an interface for the security guards. Or our famous example is Getir Yemek. Bring people, bring drivers, bring restaurant owners, bring customers, bring them together and let them discuss. Also, there is a facilitator, there is a moderator. Sometimes there is, sometimes she walks away. Number of individuals is 3 to 10. Let them discuss issues and watch them, what they discuss and what they conclude. You will start with set of structured questions and then let them go through the questions, and after that allow some different talk so that see what they are talking as problems. Audio video recording is essential, and by doing that quickly you learn a lot, and it is a known study, and it is accepted by the company, it is accepted by the managers, and also it is accepted by the developers. So some usability labs have these meeting rooms with audio video recording capabilities, basically a camera. So they discuss the product. This could be customers, potential customers, or existing customers. So focus group study has been implemented for many years in product design. Now we are implementing it in software design. Okay. And lastly, if there is a documentation, legal documentation or other kind of documentation, you should study and review the documentation that is already available in procedures. So, and also try to understand why things are not done by the book. There will be reasons, of course. Try to understand those reasons. In the design of your product, your interface, you should also look at the competitive products, looking for both good and bad ideas in the market in terms of functionality, in terms of style, and make a table like that. These are the things that are considered as important. So this is what you have, this is the other competitors. So try to understand whether these metrics limit your system or not. With good and bad parts. We have been talking about immersion, ethnographic studies, observation, interview, think loud, question forms. So which method or focus groups, which method we are going to use depends on resources, current knowledge of tasks and users. What do you know about tasks? What do you know about users? And what is the context? For example, If tasks involve two people working together, how do you thinking out loud can be used? How do you define it? It cannot be used. So only one person tasks is suitable for thinking out loud. Or sometimes you cannot take video, such as in banks. In banking screens, you cannot take video. So because of there's sensitive data. Some methods, such as interviews and questionnaires, are essential, but not all methods are used all the time. Try to use methods that will give most information for a particular setting, particular customer type. Study is finished. Organize information. If it is done by multiple people, if 3 or 4 researchers went to the factory and did the same thing, you should compare notes. And there are several tools that can be used to facilitate multiple data and organize information. Those tools, those user interface study or requirement gathering tools can be used, software tools. But the simple one is card sorting, like affinity diagrams I have described. Cards, write things in different cards and put them together. If they are together, probably a top menu item. They will be under top menu item. Do it with multiple users. If everybody thinks the same way, then probably they need to go to the same place. Another example of affinity diagram. So these explain how task is perceived by users. There are ways to draw flowcharts. There are tools for flowchart drawing and card sorting and task analysis diagramming. And this is okay. And it helps you to generate the software architecture, software user interface architecture automatically. But it is not necessary. It can be done manually. So I started talking about task analysis. How am I going to do it? As we said, we are going to their environment. We were focusing on how people work through things, through activities, through things, and through relations in their environment. Not only for computer system, but also the interactions. Let me focus. I did this. Yeah, I have to skip this. Okay. Now, the processing is finished. Doing is finished, but data will be presented. So how am I going to present this? Use case diagram. Characteristics plus personas. Task outlines, narratives, hierarchical network diagram, hierarchical task analysis, or flowcharts. So these are the ways to explain tasks to other developers. You did experiments, you did interviews, you did questions, you observed things, you went to factory, you understood, and this data, the collected, you took video, and this data can be put in these forms. This narrative is the brief of video. If you take the video and write them down, what is happening, that's what we call narrative. If you itemize it, it is task outline. User characteristics and personas explain how user is. What are the user's characteristics? Use cases describe the actors in the task. Hierarchical task analysis decompose tasks into smaller tasks. Entity relationship diagrams include items and actions and how they work together. And flowcharts are good for multiple level operations. And ses geliyor mu? Sese bakayım. Okay. Basic use case. Frequent user interactions are documented in the essential use case, so it's typical to use case diagram. It is used to evaluate and walk through various design alternatives. Name of the use case, what the user wants to do, what the system is going to respond. So this is what users want to do. This is the system's requirement. So, and this is the name of the use case. Multiple use cases are documented. So it will explain what is necessary to implement in the computer system architecture, the application architecture. Do not make assumptions about the user interface design based on the user use cases. It has to be studied further. Example is user intention is arrange a meeting. System is responsibilities, request meeting attendees and constraints. Identify meeting attendees and constraints. Suggest potential dates. Choose preferred date. Book meeting. So these are the intentions, use cases. These are the intentions, and these are the system responsibilities and name of the use case. Another one, identity check, authorization in the ATM. On the ATM machine, user's purpose is login. System's responsibilities validate user and identity, display currencies available, and display other alternatives immediately. Select currency required if it's an international place. Display exchange rate, enter amount of currency, calculate, confirm account, start paying, give money, take money and go. So this is what use case is. Use case definition is, and the name of the use case is get foreign currency. That is withdrawal of money from an ATM machine. Okay. And wait. And persona study is interesting. It's a nice, elegant word. It is description of user and what user wishes to do. It is explained in detailed form. Sometimes names are given. Actually, in persona, names are given like Ali, Veli, a fictitious name, not real names. And you explain who the user is, what situation, what kind of educational background, etc. It is developed by Cooper and it is widely used persona analysis, such as this is one persona example from the book. It's a young adult to middle age to senior citizens. Age 12 to 25, 25 to 50, 50 to 80. Physical limitations, educational background, IT use, motivation, and attitude. This is actually a user characterization, not persona. This is also good. So what kind of users are allowed or expected to use your system? And you will develop your system based on these requirements. So this is user characteristics study. How about persona? Persona is this. Teenage ATM users. He is 13 and gets pocket money each week. He spends its time with friends, so doesn't make regular deposits. He does receive gifts for his birthday, Christmas, etc. This is from the book, actually. Saves money for special purchases such as computer game console and trendy clothes. Has an ATM card only to make withdrawals. So it's kind of a kid using the ATM machine. A little older person, 30 years old, has 2 children. One is small, one is big. This is small one. And goes to the shopping center, and she does not drive, so has to use public transportation. So takes the baby with the baby together. So bank is on the upper floor in the shopping center, so she uses the ATM outside the first floor, and the baby is having problems, etc., due to bad weather. Grandpa, 68 years old, so gets pension from the bank account, at the beginning of each month. He goes bank every week, withdrawing enough cash for the week for miscellaneous expenditure. So old people like to go banks every week in all countries. It keeps them busy. So regular bills are paid by check, not by internet. Or standing in line for a live teller prefers social interaction to using an ATM machine. So even if the actual job can be done through the mobile application or through the internet, they don't do it, or they don't use ATM machine to make that happen. I may not have an ATM card. Task outlines or forgot. Sometimes they forgot the password for the ATM card. They cannot get it back, so they just prefer to move to the bank and do social interaction. To outline the task, we can use expanding collapsing outline tool. That can be a graduation project or master's project, master's level work. For user interface developers. Start from the top and add detail progressively over the time. And know in advance how much detail is enough for developers. Sometimes the task is simple, such as instant messaging. So if you have instant messaging application design, some too much detail is it may not be necessary. So try to detail places where there is ambiguity. It should help developers. If there is no help to developers, then you don't need to do that. You may have additional outlines and linked outlines and additional parts, subgraphs for additional specific subtasks. Task outlines are good for sequential tasks, but it's not as good for parallel tasks. It doesn't support branching well as well as flowcharts. Then we will fall to flowcharts. Start from the top. You either do or do this. Do this first option. First, second, third. First is done in 1A, 1B, 1C, then 2A, 2B, 2B, 2BA, 2BB. So what does this mean? That means my task, I have to do 1, then 2, then 3 to finish this. But 1 is actually 1A, 1B, 1C. Then after you finish 1C, you move to 2, 2A, 2B. 2B is actually 2BA and 2BB. At the last one, 3 is performed. Actually, that is 1, 1A, 1B, 1C, 2, 2A, 2B, and 3. So it is basically steps. That's why this book says use expanding collapsing outline tool, because these are detailed parts of the individual tasks. And if there is a jumping if-else relationship, so branching relations or parallel relations, you need to move to flow charting rather than task outlines. Example is using lawnmower to cut grass. Examine lawn, grass. Make sure the grass is dry. Look out for other objects. Inspect lawnmower. Check component for tightness. So these are the inspections sub-items. Check engine oil level. It could be simple enough, or you can go in more detail. If you are programming a robot, you need to define this. So the details are important if developer requires these information. Otherwise, the developer will invent these steps by himself or herself. Then it will be incorrect, mostly. Describe task in sentences, and it is often expanded in version of the list or outline. It is effective for communicating general idea of the task in narratives. So just explaining with story. It is not effective for details, branching tasks, parallel tasks, but it is good for introduction to diagrams or outlines. When you have a diagram, put some narratives also. So together, they make a good design document. Okay. Hierarchical task decomposition. Let me show it directly. This is a hierarchical task decomposition that I just did. So conduct an accident investigation, collect evidence, analyze facts, integrate facts, validate conclusions, make recommendations. So 1, 2, 3, 4, 5 will be done. But collecting evidence requires more detail. Then walk to accident site. Identify witnesses, interview witnesses, interview witnesses has more details. Also, you may have additional notes for skipping certain things. Plan 1, first do 1 and 2, then 3, 4, then 5. Repeat 3 and 4 if necessary. So this kind of flow control statements can be added. Okay. It is not purely flowchart. Flowcharts are actually better, but these are depending on the tasks. Sometimes these are more understandable. Hierarchical task analysis. And I ask this in exams from time to time. In the hierarchical task analysis, you may have fixed sequences. There are some optional tasks. There are waiting events, cycles, time sharing events, and optional discretionary events should be marked. You can do it with special symbols, or you can just say optional. Just write that optional and it will be fine. Borrow a book from the library. So this is the main goal. Plan 0. Do 1, 3, 4. If the book isn't on the shelf, do 3, 2, 4. 2, 3, 4. 1, 3, 4 or 2, 3, 4. Go to the library. Retrieve book from the shelf. Take the book to the counter. If the book is not on the shelf, find the required book. So finding required book has accessing catalog, accessing search screen, entering search criteria, identifying the book, and not the location, and then come back to the upper section. So these are tasks, these are subtasks. So this is two-level hierarchical task analysis. Another one, three-level. Write a letter, get supplies, write the letter, prepare envelope, prepare mail, get address, apply stamp, find address book, find address, prepare to mail, insert letter or seal envelope. So these are the required sub-steps, subtasks for the goal. Same task analysis may have two different interpretations. Get envelope, paper and pencil, get envelope, paper, pencil, write letter, write address, then address the envelope, write letter. So these may swap. Apply stamp, put letter into envelope, seal envelope, seal envelope. So sometimes small differences can happen, but that's okay. That is the nature of the interaction. In reality, this is also true. Schedule a meeting, arrange a meeting, compile a list of meeting attendees, compile a list of meeting constraints, suitable date, find the suitable date, enter the meeting info into calendars and send the calendar request. To find the suitable date, identify departmental dates, identify individual dates, compare dates, and choose preferred. So again, this is two-level analysis. If this doesn't help, sometimes a lot of jumping occurs. If there are a lot of jumping occurs, we call it as network, an entity relationship diagram. In those, objects and people with links to related objects and actions are marked on arrows. Usually, objects are circles or boxes, depending on how you draw. Links are related to functionalities. So let's see. There are objects, relations, actions, and objects. Let me have one example. Where was it? Let me draw it. File, line, characters. So comprise. This is user. Delete. Edit. Okay. Delete. Edit. Not edit. Delete. Insert. Move. Etc. This one, rename. So it is basically entity relationship diagram, ER diagram, similar to databases. So the boxes contain objects, whereas lines and arrows contain actions. That is what network entity relationship diagram is. The last one is flowchart. In the flowchart, entity relationship diagram is combined with sequential flow. So flow and relation is combined. It includes actions, decisions, logic, and also the flow. It's a good tool. There are well-known applications to improve your flowchart. I do my flowcharts in PowerPoint, Microsoft PowerPoint. The reason is that I can share it easily. I can develop it easily. I can import, export easily. There are very nice tools to make flowcharts or diagrams online or free downloadable applications, but importing, exporting, sending that to other people, editing with multiple people becomes very difficult. So my suggestion is, if you are going to draw something, use well-known, simple tool. This is like start, continue, document, manual operation, input, and just to say example, and this helps a lot. So please do flowcharts in your applications for the user interface, for the scenario. Such as documents going from one person to another. Let's see. In the workflow example, it's a data flow. You have an invoice, for example. You have a document. Document flows in the organization. So rather than program flow, you focus on document flow or workflow. What happens to things? So the flowchart shows the data progress. For example, you have the data and it is processed by, this is data, this is processed by P1 and then processed by P2, P3 and so on, and that will be output. So this kind of flowchart is not the flowchart of the application, it is the flowchart of document flow. That is different. Also very helpful if you are focusing on the steps involved. Another one, similar to entity relationship diagram, but document oriented. So what happens to document is displayed here. That's from the book again. So actually, this is an important part of the software engineering, task analysis and user requirement gathering. And it is crucial in developing good user interfaces and usable applications, because many problems are due to lack of understanding of the task by the developer. So what we do is first determine the data we need to gather. We collect it using various methods and techniques and represent tasks and subtasks. Please document, so write and draw. So generate documents. Do not copy and paste. Copying and pasting from internet, from various resources, just to just to make good looking flowchart is not sufficient. Obviously, you can copy, but actual task information, actual architecture must be documented. And to improve design, this data we generate should be used in a usable form, then also be efficient. Yes. Let me give 5 minutes break. And come back at 11:50.
Okay, sure.
Okay, I am back. So now we should focus a little bit on effect of user and task attributes. How attributes of users and tasks influence the design of user interfaces. So tasks are fine, but how are the attributes important? Are there some design guidelines that we can derive from these different attributes, user attributes and task attributes? Let me focus on that. Such as user attributes, attitude, motivation, reading level, typing skill, education, experience, task experience, computer literacy, frequency of use, training, color blindness, handedness, left-handed or right-handed, gender, or beginner, intermediate, expert. So what kind of experience with the system? These are the attributes of the user, occupation, etc. So, for example, the motivation. When the user have low motivation and the use of application is optional, meaning discretionary, then our design goal must be easy learning. Otherwise, your product will not be used. This is true for games. This is true for free applications. Motivation is low, and they may not use it. So it must be easy to learn. But if it's a job application, job system, like government application system, computer application system, motivation is low usually, and but the use of the system is mandatory. For example, you are going to use e-government website. In that case, the design goal is control and power to users. So users should feel the power and control rather than ease of learning. Your interface should give the feeling of the power to user and control. That also increases the motivation. Since it is mandatory, ease of learning is not that important. It is important, but not that important as a priority item. If user has high motivation due to fear, ease of learning, robustness, and control is necessary. But high motivation due to interest, because it's an interesting thing, then power and ease of use is important. So generally, optional things must be easy and learning curve must be very fast. But if there is a fear there is a lack of motivation, if people have to use but they are having problems, then control part, power part is more crucial as a design goal. This is one interesting fact. How about experience? If the experience on task is low and experience on the system is low, it's a beginner, the design goal should include many syntactic and semantic prompting. Do you want to continue? Please enter blah, 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 following. Now go there, now do this, now do this, now do that. So if it's like an ticket machine. If it's a ticket machine, my experience is low because I'm a tourist. System experience is also low. I don't know where to go. I don't know where to go. I don't know the jargon. When I was in Ankara some years ago, I asked the infodesk person in the train station, saying that does metro goes to Batıkent? And he says, that's me, him. He says no. I said okay. He said Ankara goes there. I was shocked because I didn't know what Ankara is. Apparently, in their jargon, metro and Ankara was two different things. So my experience with the task was low. My experience with the system was low. So many syntactic and semantic prompts were necessary. He should have asked, where do you want to go? You should take Ankara as a train, because there are two types of train. So prompting was necessary to correct me. Today we have U and M signs in Istanbul, for example, for different types of railway systems. Also we have Marmaray. Some people may say metro doesn't go there, but Marmaray does. So you don't understand. A foreign person cannot understand. When the experience with the task is high and the system is high, efficient commands, brief syntax is sufficient, and it speeds up. Speed is the goal. Okay. When the task knowledge is low, but system knowledge is high, semantic help facilities are helpful. Syntactic help is not that much required. When the system experience, when the task experience is high, but the system experience is low, syntactic prompting is required, because person is unable to use the system efficiently, but knows the task. So he knows where to go. So semantic prompt is not required, but syntactic prompt is required because system knowledge is low. So system knowledge is syntax help, semantic help. Semantic means help. Semantic means explanation. Syntax means direction, guidance. Guidance and commands, like using menus, etc. Some tasks are different than others. For example, some tasks are very highly repeated. Highly repeated tasks must be easy to accomplish. Less frequently used tasks require ease of learning and remembering, because you don't have to do it very fast, but it has to be easy to learn. How easy to learn? Similar to others. similar to many. If you make the task similar to many other tasks in the application or in the environment, then even if it is not remembered 100%, learning becomes easy. Even if it is not efficient, even if it requires multiple steps, since those steps are natural, then learning is easy. But if it is frequently repeated, you may develop something interesting. If it is easy to use, it is okay. It's better. High frequency task is easy to use. Low frequency task, ease of learning. If you have to use the system, it must be easy to use, such as government, office, belediye. Okay, because the person user is using all day. It must be easy to use. It must be fast. If it is an optional thing, used from time to time, optional, then it must be easy to learn. Such as games or recreational applications. Now we come back to interface evaluation. In the following slides, we will be focusing on evaluating existing designs and existing applications. We have gathered requirements, designed the system, built the system, but does it fulfill the user's requirements? Now we have to understand, repeat, usability, basic evaluation styles, basic evaluation definition, evaluation of the design, and evaluation of the implementation. Evaluation is done in two forms. You can evaluate design, you can evaluate implementation. How do you evaluate design if it doesn't exist as a product? Yes, you can. You can evaluate design by certain techniques, by imagining or by going over it on the paper prototype with the user. I am going to explain that. What is evaluation? I'm going to make an introduction and leave. Evaluation by experts and end users is an important part of the user-centered interface design. Because usability is the major objective of the design process, you need to know the valid scientific methods of evaluation of the interface that have been developed and how you can apply them within software lifecycle. Kolay. I'm switching to Turkish. Kullanıcı dostu. User friendly. Easy. These are debatable subjective statements. So we need to find a way to scientifically conclude to certain results. That's why some people still believe that user interface design is not a scientific thing, it's more like an artistic thing. Actually, it has both sides, but scientific methods apply to user interface design and evaluation. If we can evaluate user interfaces with scientific methods, meaning that repeatability, measurability, hypothesis, and validation. So if we can achieve those scientific methods with the user interfaces, then we can say A is easier than B scientifically. So if it's product A and product B, or user interface A, user interface B, we can say that user interface A is more functional and more usable. So we can buy this, we can develop this part rather than the method B. This is what we call A/B testing in the industry. Therefore, we need to understand scientific methods, and most scientific methods are relying on measurement. There are two major method tracks. First one is the heuristic evaluation. Second one is the user testing. Heuristic evaluation is also very important and has basis. User testing is actual laboratory or field testing. Let me explain what we mean by heuristic evaluation and then user testing. What is usable? Efficiency, effectiveness, and satisfaction. Remember, utility is the functionality of the system. So utility must be provided. These three things must be provided. Utility without usability is possible, but not vice versa. So something cannot exist with usable interface, but not functioning interface. So it has to function plus usable. Good usability paradigms do exist, such as graphical user interfaces. If something has graphical user interfaces, it is usually, unless there is a reason, it is usually considered as a good interface. We need to know why something is usable. And we really want principles to guide developers. We don't want art. Okay? So good and bad should not be nice and ugly. Nice and ugly is something different. Good and bad is measurable, quantifiable thing, explainable characteristics of the user interface and usability. So if something is good, what is good? Good means it is functional, it is usable, it is maintainable, it is reliable and portable. This is from software engineering. So this is quality parameters, system quality characteristics and quality parameters. So system evaluation is the process of gathering information about the quality of the system. So what is usability then? It is quality perception. Quality perception by user is usability. Whether the system is functional, whether the system is maintainable, is it reliable, is it portable? If I think it is reliable usually. So usability is from the eye of the user. It focuses the user's perception of the quality of the system. So interface evaluation is actually user's perception of the previous software engineering characteristics. So it also includes functionality, maintainability, reliability, and portability in addition to usability. And it involves evaluating the categories listed in the previous slide from the end user's point of view. By evaluating the interface of an interactive system, improvements can be made that will lead to a more usable and useful system. So that is very, very important. Why do we evaluate? We do evaluate, we criticize because we want a better software. We want to develop it. If we say very good, very good, very good, very good, then we cannot improve. Therefore, we need to criticize, we need to focus on problematic areas. Interface evaluation should include comparison of aspects of the interface to the established interface guidelines. In the last lecture, in the last two lectures, we talked about superior interface characteristics, and those superior interface characteristics are looked for during the interface evaluation. Evaluation can occur at various stages in the interface design process. At the end, it concludes with the user acceptance testing. First evaluation should occur before any implementation work has started at the design level. Final evaluation should occur during active use on the market by collecting data. This is ISO standard. ISO 9241. That's from 9241 and also from the research. User-centered software lifecycle. We design, we implement, we evaluate, and go back. Also, we design, we evaluate, we go back. Before implementation, we evaluate our design, then implementation was also evaluated. It's a cycle. When do we stop? We stop when we run out of money. Obviously, I'm joking, but we stop until we are satisfied or until the company time limit is achieved, is reached. We do our design through requirements and task analysis, usability testing, principles and guidelines, and experience. So we come up with a design, we evaluate our design and then implement. Then through the usage data and through testing, we evaluate our implementation and we make it better for the next release. Continuous evaluation is critical. Some software engineering books require spiral model. This is also that is Boehm's model. Software spiral model, inception, elaboration, and implementation phases. Basically, design, implementation, and evaluation in multiple cycles. These phases in Boehm model correspond to different phases in software engineering activities such as design, coding, evaluation, and restructuring. That is the first iteration, second iteration. So each layer in the onion corresponds to new iteration of the same activity. Remember this Nielsen principles. So these Nielsen principles, there's just 10 principles. There is more than 10 actually in reality. So in the interface evaluation, it is not an AND operation. Some people say testing, testing, testing. If testing is done at the end, for example, you have 18 months project. If you do testing at 17th month, so 16-month development, 1 month testing, 1 month integration. This is wrong, because once you do testing, what if you find it is incorrectly designed? The time is passed. So in these cases, testing reveals, okay, very good. People say it is very good. Nobody says it is bad, because if anybody says it is bad, you have to rewrite the application. Therefore, testing must be done in the early phases, not only at the very end. We test to improve, not to prove. Okay, that is very important word. Design must be tested at various times during the life cycle, and prototypes, alpha and beta versions must be tested. This saves a lot of time and money. Many types of evaluation does exist, and trick is to choose the appropriate one. The purpose is to uncover usability problems. Okay. There are some thoughts such as recall and recognition, making system easier to use, make it powerful. Humans can switch topics fast, such as multitasking. Computer system should be able to do the multitasking. Complex syntax hides the task, needs directness of the interaction. So there are principles. These are examples. In this case, there are different evaluation stages. Evaluation can be done in the design and at implementation. If you have a working system, that is implementation evaluation. If you have a non-working system, you have design evaluation. And you may have cognitive walkthrough, heuristic evaluation, review-based evaluation using models can be done. In the implementation evaluation, you can have empirical experiments, you can have observational evaluation, and you can have questions, as we have discussed. So next week, we will be doing these evaluation and experimentation in more detail. Stopping the recording.